Hello everyone. I'm really excited because this is actually my first video presentation and I'm very happy to share it with you. Today, I'll be combining two things I truly enjoy: physics and board games. Many people think physics is only about complicated formulas and equations, but in reality, physics is everywhere, even in something as simple as fun as board games. In this video, I will show you how important concepts like rotation, angular velocity, moment of inertia, torque, and angular momentum can be clearly understood using a spinning mechanism from my board game. I hope you enjoyed this demonstration as much as I enjoyed preparing it.
Hello everyone. In this video, I will explain the physical concepts of rotation, angular motion, and torque using a board game as my area of interest. Board games may seem simple, but many of them use important principles of physics. The game I'm using has a spinning mechanism, which you can see here. Similar to a spinner or rotating wheel, which is fixed in a place using a magnet. There is a magnet here. And this makes it a very good example to understand rotational motion. First, let us talk about rotation. Rotation is the motion of an object around a fixed axis. In this board game, the spinner rotates around the central axis. Even though the spinner moves, the center point stays fixed. This is the center point, x-axis. And it's held in the place by the magnet. This is different from a linear motion, where an object moves from one place to another. Here, the spinner stays in the same location but turns around its axis. When the spinner turns, it covers an angular displacement. Angular displacement is the angle through which the object rotates. It is usually measured in degrees or radians. In IB, we prefer using radians, so it's easier for us in that. If I spin the board game spinner slowly, it has a low angular velocity. Angular velocity tells us how fast an object rotates. If I spin it faster, the angular velocity increases. Even though the spinner looks small, its angular velocity can be quite large if it spins quickly. Next is moment of inertia. Moment of inertia is the rotational equivalent of mass. It tells us how difficult it is to change the rotational motion of an object. In the spinner, the mass distribution matters. If more mass is located farther from the axis of rotation, the moment of inertia increases. That means it becomes harder to start or stop the rotation. This is why board game spinners spin longer than others, but it's not the same situation for this because of both the friction force and the magnetic field. It doesn't spin after I turn it. And I would like to talk about torque too. Torque is the force that causes rotation. It depends on two things: the amount of force applied and the distance from the axis at which the force is applied. When I try to turn it here, I use a lot of force, but it moves really hardly. From the middle, if I apply any force, it doesn't even move. But when I try to spin it from the outside, it becomes really easy for me to turn it. This is because of the fact that the R is longer here. The distance of R is longer. And when I try to spin it from here, the R is smaller. And angular momentum. Once the spinner is rotating, it has an angular momentum. Angular momentum depends on the moment of inertia and the angular velocity. If there is very little friction, the spinner continues to rotate due to the conservation of angular momentum. In this board game, friction with air and contact with the surface slowly reduces the angular momentum, causing the spinner to stop. And in conclusion, I would like to say that in physical concepts like board game, rotation, angular velocity, moment of inertia, torque, and angular momentum are really important in order to make a game like this. I want to become a board game designer too. That's why I need to know these physics elements in order to achieve my goals in the future. Thank you for watching my video.